All right, we are now in section 4.5, which covers compound inequalities. Now, we're going to go with a very basic, back to elementary school type problem. I just want you to listen. If I asked you to write a compound sentence, what does that mean? Not math related, just a plain old compound sentence. So you could say something like, I went to Target. I went to Walmart. So if you would actually take those two sentences and write a compound sentence, what could you say? Instead of saying, I went to Target, I went to Walmart, what could you say? I went to Target and Walmart. That is a compound sentence. We are going to use that in today's lesson, which is talking about compound inequalities. The definition of a compound inequality are two inequalities joined by the word and or the word or. We're just going to start off with a real-life problem to show you how compound inequalities really work. A wrestler can only weigh more than 100 pounds, but no more than 120 pounds for a certain weight class. So let's just graph this. Whoops. All right. So 100, I'm going to count by fives. 100, 105, 110, 115, 120. So a wrestler can only weigh more than 100 pounds. More than 100 pounds means he can't weigh 100. So it'd be an open circle because 100 is not a solution. But no more than 120, which means he can weigh 120 pounds. What weight could he be? It'd be anything in between, including 120. You can't include 100, but you can include 120. This actually is a representation of two inequalities put together to make a conjunction, which we'll talk about in a second. Here's the first inequality, x. What do you know about x? Just looking at this side, don't look over here. X, can it be 100? No. Where is it? It's greater than 100, and x represents his weight. The other inequality can be less than or equal to 120. Now, we combine these by using the word and. X is greater than 100 and x is less than or equal to 120. The other way to write this would be to write 100, which is less than or equal to his weight, which is x, which is less than or equal to 120. Either one of these mean the same thing. I can take this inequality and reverse it, and it's the same thing. If x is greater than 100, then 100 is less than x, which is also less than or equal to 20. What this means is his weight is between 100 and 120, but also includes or is equal to 120. So a conjunction is a compound inequality joined by the word and. So let's do some examples of this. Example number 1. Today's temperature will be above 32 degrees Fahrenheit, but not as high as 40 degrees Fahrenheit. Write and graph an inequality that represents the situation. So I'm going to let T be the temperature. It says that the temperature has to be above 32. Above 32 means it cannot be equal to 32, but it has to be greater than it. So T is greater than 32. And T also has to be not as high as 40. So it can't be 40, but it can't be as high as that. So it has to be less than 40. So we can write this as a conjunction. 32 degrees is the lowest. The temperature has to be greater than that, but it has to be less than 40. This would be read as 32 is less than T, which is less than 40. This is a conjunction. This also states that T, the temperature, is between 32 and 40. If you graph this, whoops, I don't want that. Let me get rid of that. So 32, 34, 36, 38, 40. I'm going to count by twos. So we cannot be 32. We cannot be 40 because They're open circles, so that means they are not the solution, but the temperature can be anything in between them. All right, we are going to do this problem in two different ways. However you do it, it's up to you. Solve and graph. So it says -4 is less than r minus 5, which is less than or equal to -1. Now, one way to do this is to separate it into two separate inequalities. Now, I will tell you that if you see something that looks like this, a compound inequality, it is automatically an and problem. Automatically. So, you could take this inequality here, and you could write it as -4 is less than r minus 5. You could then take the other inequality and write it as r minus 5 is less than -1. And we could separate it by the word and, which you must put there. Now, if you solve both of these, this would just be adding 5. That means 1 is less than r. And if we add 5 on both sides in the other inequality, you get r is less than or equal to 4. So if you graph this, so you could write this as your answer. If we graphed it, 1, 2, 3, 4. R is greater than 1, therefore we have an open circle. R is less than or equal to 4, and we can shade in between. That's an and problem. Now the second way to do this, on your homework you do not have to do two separate ways. You can just leave it the way it is. And now you have almost like a double inequality. So instead of adding 5 to just two sides, you're going to add 5 to all three sides. Notice down here that you added 5 on this inequality and this one. So you can just do it to all three sides. Pretend, if you want to, that you have like 3 parts to this. You have a left, a middle, and a right. You have to do everything to all 3 parts. So if you add 5, that gives you 1 is less than r is less than or equal to 4. So if you drew your graph, r, it says 1 is less than r, so that's not equal to, so it has to be open circle. R is less than or equal to 4. It can be equal to. And since it's an and problem here, we're going to shade in between 1 and 4. So either way, you're going to get the same answer. You can separate it into two separate inequalities or leave it as one. Let's do another example, but I'm only going to leave it the way it is. So example number 3. 7 is less than -3n plus 1 is less than or equal to 13. The first thing we have to do is get rid of the plus 1. So I'm going to subtract 1 from all 3 parts. That gives me 6 is less than -3n is less than or equal to 12. The next step is dividing everything by -3. That would give me -2n and -4, but this is your big thing to remember. Don't ever forget this. Because you divided by a negative, your inequalities all reverse. So, your answer would state -2 is greater than n, which is greater than or equal to -4. Now, this is just something that's a rule in math, is that when you flip this, conjunctions or and problems are always written with less thans, like they're always less thans. Because these are greater thans, we're going to flip the whole thing. Now, it does not change the problem. I'm just reversing it. Remember how you can take m is greater than 2? It's the same thing as 2 is less than m. When you have a compound inequality, you always should go from lowest number to highest number, and you should have less thans. So if you see that your end result is greater than, just flip the whole thing around. You don't change anything. You just reverse it. But it doesn't change the meaning. What does this state? It says that n has to be less than -2, but greater than or equal to -4. So if you graph this, we have -4, -3, -2. It says greater than or equal to -4, so I can have a closed dot, open dot on -2 since it's just less than. You shade everything in between. Now, a disjunction is a compound inequality separated by the word or. A solution of a compound inequality joined by or is any number that makes either inequality true. That's an important thing I suggest you write down. Either inequality true. A conjunction and has to make them both true. So in example number 4, we're going to solve and graph the compound inequality x is less than negative 3 or x is greater than 7. You cannot write this together like you can the and problems. It just is going to be like this. Here's the great news. Or you just graph it. So let's just graph them. We have negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. So we graph the first one. X is less than negative 3, open circle because it's not a solution, shade to the left. X is greater than 7, open circle, shade to the right. That's your answer. Notice how we shaded outward. Most or problems are shaded outward. Most and problems are shaded inward. That, however, is not always the case. So we'll get to that in a second. So in part B, we're going to do the same thing. We're going to solve it. So let's solve both inequalities. I subtract 3 on both sides. That gives me 4y is less than negative 8. I divide by 4. That gives me y is less than negative 2. My other equation, I subtract 7. I get negative 2y is less than negative 6. I divide by negative 2. That gives me y is greater than 3. One thing I forgot to do is bring down the or. That's an easy thing to forget. Always make sure the or comes down for each problem. So now if I graph this, negative 2, negative 1, 0, 1, 2, 3. Y is less than negative 2, so open circle since it's not a solution, and shade to the left. Y is greater than 3, so it's not a solution. I put an open circle, shade to the right. And there's my answer.